I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 28th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
There's some big changes going on subsurface in the central Pacific Ocean. Cold water that once was in place is on the move. We'll get into the details in a little bit, but let's start with the basics. Looking at significant wave heights for the North Pacific Ocean, we see a gale generating 22-foot seas over the North Dateline region. This is going to continue to push off to the east, generating some small swell of interest for Hawaii and the U.S. West Coast. But first, let's go take a look at the jet stream. This is where everything really gets going. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We have a good, healthy flow of the jet pushing off Japan down at around, 30 north, and then building with winds to about 180 knots over the Dateline region, falling into a steep trough that's all but pitched off here north of Hawaii, and then remnants of that energy are pushing into British Columbia, generating an atmospheric river, a wet flow pushing into the coast there. Moving forward, we see the beginnings of a trough trying to organize here on Monday over the Dateline region. That is a dip in the jet to the south. That helps create a counterclockwise flow aloft. And down at the ocean surface, that's the hallmark of low pressure. And low pressure generates winds. Winds, as they get traction on the ocean surface, turn into seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. So troughs are important for generating swell. They are the upper level foundation for all swell and storm production. As we get into Monday, that little trough, and it's not much one, pushes off to the east, Tuesday into the Gulf, and then notice over here as we get into Wednesday, the jet starts splitting heavily with some energy falling south, some energy pushing north. That's not really a good thing. That tends to support high pressure between the split jet stream flow. But also notice this northerly branch of the jet starts dipping south as we get into Wednesday, trying to carve out a new trough in we'll call it the northwestern Gulf of Alaska. That builds a little bit more into Thursday, digging way down to the south, maybe supporting gale development there. And notice here now, the split jet stream flow heals itself on Friday, but winds still at 170 knots. They start falling down into that trough while building to 190 knots as we get into Saturday. And that sets up a really large-scale, deep trough just north of Hawaii on Saturday. That should certainly be supportive of gale development. A little bit pinched, but you take what you can get. Look at that, just 190, 210 knot winds pushing up into the Bering Sea. Then 180 knot winds falling due south, raking over Hawaii, ridging again high pressure off of California, and then pushing into the Pacific Northwest. So a pretty high amplitude pattern for sure, and then that trough starts pinching off as we get into Monday, a week out. So at least there is some opportunity for swell production over the next week. It looks like from an upper level perspective. Let's go take a look down at the ocean surface. Here we are, surface level pressure, surface level winds, low pressure, what's that, about a 968 millibar low right here. That is the Aleutian Islands, dateline at 180 west. So right there on the dateline, we call it the North Dateline region, just barely free and clear of the Aleutian Islands. 30-35 knot westerly fetch there, getting some traction on the ocean surface. We saw that on the previous significant wave height chart. That continues into the Gulf as we get into Monday with a small patch of 45 knot winds, and then the secondary fetch here down here to the south at 35 to almost 40 knots continues Monday night into Tuesday, and then pushing into central Canada at that time. But lingering secondary fetch, well, actually it'd be tertiary fetch, continues in the northern Gulf of Alaska on Wednesday night into Thursday. And even maybe beyond that, also notice low pressure starting to build from that developing trough here north of the Hawaiian Islands. Even as we're into Thursday morning, still 30 to 35 knot winds building over the northern Gulf of Alaska. A cutoff low develops here west of Hawaii on Thursday, but all fetch is aimed off to the east, of no interest to Hawaii whatsoever. But as we get into this, you can see come Friday, the trough is set up right sort of along there. High pressure, 1040 millibar, 1044 millibar high, bulletproof west of the trough, but east of the trough, fetch building right here due north of Hawaii. So that's, let's see, 300, 600, about 700, 800, and 800 nautical miles north of Hawaii, aimed a little bit west of the islands, but still sideband energy pushing well towards Hawaii. And then as we get into Saturday, 45 to 50 knot winds aimed due south at Hawaii in fairly close proximity. That should certainly generate some swell indeed. As we get into Sunday, it continues pretty much just locked in place right there. And then where are we? Sunday night, it finally starts fading before we get into Monday as high pressure builds off of California. But another system looks forecast over the North Dateline region. Of course, this is a week out. If you believe the model's a week out, well, I have a bridge I want to sell you. But so we don't believe any of that, but at least it gives us some hope. Looking at significant wave heights for the North Pacific Ocean, we're going back to Friday. So what's that, about 2 days ago? A little gale developed here over the North Dateline region, generating 23.5 foot seas. This is the highest seas over this whole domain. You notice here you can pick out the exact coordinates, 43.75 north, 178 west, right there. Max winds at that rough same location, 40 knots. So 40 knot winds, 23 foot seas right there. And that built a little bit into about midday Friday. 25 foot seas peaked out right there. And then this system kind of faded from there. Swell is in the water pushing towards Hawaii. I think it's going to arrive on Monday. And then into the U.S. West Coast on Wednesday. Whoops. And then today, Sunday, let's go back to 12C. That little gale started building over the North Dateline region, pushing off to the east. And then moving forward, the gale is forecast to continue build with it says 30 foot seas, but we'll say 29 foot seas here over a small area. Most of that probably bypassing Hawaii bound for, we'll say Point Conception northward, something like that. Building to 30 feet, pushing into the northern Gulf, secondary fetch, building 20, 22, 24 foot seas, pushing to 25 feet. Monday night into Tuesday, pushing through the Gulf of Alaska. Sideband energy forecast down into California, probably in the Thursday, Friday time frame sort of thing. And then we're waiting for the big new trough to set up north of Hawaii. And there we go. Seas starting to build on Friday night to 27 feet, to 30 feet, and 32 feet. A little bit more, maybe 33 feet Saturday morning north of Hawaii, continuing and then fading slowly through Sunday. You can see, actually go back here just a little bit, you can see those are 18-foot seas so that's 17, 16-foot seas directly impacting the Hawaiian Islands on Sunday. Probably pretty raw, probably pretty stormy, but nonetheless, swell somewhere in select protected nooks and crannies, if we're lucky, if the models verify. Looking at winds in the Hawaii and California swell window, pretty light wind pattern right now. Weak high pressure just off the California coast all through the Thanksgiving Day weekend. Light winds, glassy conditions along the California coast, and there was swell. Pretty nice, can't complain. Thankful for whatever surf we can get. Hawaii has a light northeast wind trade flow, building a little bit more onto Monday, maybe to 20 knots, where a more or less light wind regime continues for California. Tuesday, north winds building 15 to 20 knots off the California coast from Point Conception northward, but maybe much lighter near shore. We looked at the near shore wind models, and they're still saying pretty much calm, at least in the mornings, maybe a little bit stronger in the afternoons. Trades continue for Hawaiian Islands on Tuesday at 15 knots. Wednesday, pretty much the same pattern. Wind, if anything, dying along California. Trades 10 to 15 knots for Hawaii. Thursday, pretty much the same drill. And then we get into Friday. Notice high pressure trying to get a nose in here. Cape Mendocino, 20 to 25 knot north winds. Hawaii, light winds, at least for the moment. And then we get into Saturday. Things get very much different for Hawaii. This northwest Kona trade wind, or not trade wind, wind flow starts setting up. I think it's the first one of this season so far. 20 knot northwest winds, light winds relative to California. Saturday, pretty much the same deal. Look at how close these winds are to the Hawaiian Islands right there, and pretty good velocity. Winds not so strong as we get into, actually, let's go back. It looks like about, probably Saturday night, the winds start backing off for the Hawaiian Islands. A little bit of a northerly flow, mainly isolated to the North California coast on Saturday night. Sunday looks pretty windy for California. Hawaii, a southwest wind flow, and probably some rain associated with that. And then we're into Monday, high pressure building off California, and winds for sure. Hawaii, a south wind event. Not event, but just light south winds. Next up, precipitation potential for California. The short of it is not a whole lot. High pressure in control. The jet, atmospheric river, all just aimed right at British Columbia. They've been getting doused. Whistler getting good snowfall recorded lately. They are open at least at the top. I'm not sure about the bottom, but there is snow the whole way down to the village level there. But anywhere south of there, probably not so much. High pressure in control. No rain for California at all. We're just going to blast through this. You see literally nothing. Now, where's Hawaii? Right there. You can see the low winding up on Saturday. Rain. Sunday for Hawaii. And we're 180 hours out. Still rain for the Hawaiian Islands and nothing for California. Now, that model went out a week. The snow forecast dashboard for Olympic Valley goes out 10 days. On December 6th, there is a hint of dropping, you can see it here, dropping snow, freezing level and precipitation with maybe 14 inches of snow for there. Hard to believe. We don't believe a week out, much less 10 days out, but we've been looking at a bunch of models, the longer range models that go 10 days to 2 weeks out. And they're all suggesting some sort of break in the high pressure pattern off California, the jet stream moving down into the Sierra, and rainfall occurring somewhere. And we've seen it anywhere from the 5th, that was the 5th maybe a couple days ago, to as late as the 9th, depending on which model you're looking at. But all the long range ones for right now are suggesting a break in the beautiful weather and a return to a rainier pattern, which would be very good. We'll take what we can get, and I'm sure all the ski resorts up in the mountains would appreciate that as well. And you can see here real quickly the snow level currently 12,000 feet, pushing to 14,000 feet on December 1st, was that Wednesday, continuing, and then maybe starting to trickle down a little bit as we get into later this week, the 3rd and the 4th. But then as we get to December 6th, a precipitous drop with the freezing level going down to 3,000 feet. Don't believe that, but still, if we can get below or at the base for Olympic Valley at about 6,200 feet, that would be a good thing for all the ski resorts in Tahoe. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation? That's our medium range surf indicator. By medium range, we're saying going out maybe 3 or 4 weeks. And then the El Nino Southern Oscillation, that takes us out a year, maybe even 2 years. As usual, we start by looking at winds on the equator across the Pacific. We're looking for signs of the active phase of the MJO, the Madden-Julian Oscillation. There's 2 phases, active and inactive. The MJO rotates west to east on the equator. On one side of the planet is the active side. On the other side is the inactive phase. When the active phase pushes over the Pacific Ocean, it takes about 3 to 4 weeks to make its journey across the Pacific. What it does it's effectively a low pressure system. It reduces, if not out and out reverses, trade winds. It imparts energy to the jet stream, therefore helping to fuel troughs that we talked about earlier, and therefore helping to build gales, which in turn produce surf. And then it also can help take warm water that's over in the far west Pacific, and if the active phase is strong enough and it reverses trade winds enough, it can then take warm water in the West Pacific, push that off to the east in what's known as a blob of warm water, a Kelvin wave, and that takes, again, about 3 months to traverse the Pacific, but when it impacts Ecuador, it can then start erupting to the surface there, warming ocean temperatures off of Peru and Ecuador. If you get successive active phases of the MJO, they can help to usher in El Nino. Of course, right now, we're in a La Nina state. We're in the exact opposite, where the inactive phase of the MJO is dominating. Trades are stronger than normal. There's a lot of upwelling in the East Pacific, and in turn, all the warm water is balled up in the far West Pacific, and it is immovable at this point in time, being held in place by stronger than normal trades. All right, so let's take a look. Data from the TAO buoy array. We're looking for signs of the active phase of the MJO. This is the West Pacific here. That's New Guinea. Here's the equator. This is the East Pacific here, at 95 west, so a little bit west of the Galapagos Islands, but close enough. The temperatures the colors are actually sea surface temperatures. You can see colder temperatures in the east, warmer temperatures where the data is available in the west, but it's really the arrows we're looking at. These are 5-day average winds. The arrows are from the east going to the west, so strong easterly trades. The longer the shaft on the arrow here, the stronger the trade. So it's very strong easterly trades in the East Pacific. Same thing over the Central Pacific. And in the West Pacific, the Kelvin wave generation area, when the active phase moves over the West Pacific, there's the date line right there. Anywhere from the far West Pacific to about 170 west, 5 degrees north and south of the equator, and it reverses or dampens the trade winds here, can take this warm water, push it off to the east like we talked about before. But it's not the actual wind speeds, it's the anomalies, differences from normal for this time of year. Certain times of the year, the trade winds always blow much stronger than normal. Other times, not so much. So you have to compare that to normal. And what we see is, yeah, trades are blowing pretty hard in the East Pacific, but looking at the arrows right here, they're kind of like all over the place, meaning trades are pretty much normal for this time of year. You get to the Central Pacific, yeah, there may be a little bit stronger out of the east, but not too bad. But in the all-important Kelvin wave generation area, again, this is when the active phase moves over here. It not only can generate Kelvin waves, but this is where it does its best to impart energy up into the jet stream and fuel storm development. Trades are stronger than normal, indicative of the inactive phase of the MJO. Let's go look a week ahead, all right? So this is kind of a strange chart if you haven't seen it before. It's winds over the entire planet, not just the Pacific Ocean. And it's not the actual winds, it's only the east or west component of the wind. Is the wind blowing harder or stronger than normal out of the east or west? The reds here are stronger than normal westerly anomalies. The blues, purples, are stronger than normal easterly anomalies, typically associated with the inactive phase of the MJO. This here, typically associated with the active phase. We want this to be over the far West Pacific, the Kelvin wave generation area. All right, so let's get oriented. Where are we? Well, the date line, 180, right there. Goes right up the middle of the chart. Far West Pacific starts about 135 east, so right about there. So you can see, just knowing that, we've had easterly anomalies just dominating the Kelvin wave generation area for months, literally since July. But then you noticed, just right here, starting today, westerly anomalies for the first time in forever building or forecast to build almost to the date line. And the core of this red here moving into the West Pacific. This is a pleasant surprise. 5 days ago or a week ago when we last did the video, there was some hints of this, but then we kept watching day after day. We didn't do this on video, but it all looked like it was going to fall apart. Now all of a sudden, ta-da, we're back in business, it looks like. This is good news. So this suggests that maybe the active phase The first active phase in a very long time is supposed to start building over the West Pacific. This is very good news. So let's go look 2 weeks out. These are outgoing long-wave radiation models. Basically, cloud cover. The blue, more cloud cover, less sunlight reflectivity off the ocean surface. Yellows, more sunlight reflectivity off the ocean's surface. All right? If you have more clouds and they're sort of all in a cohesive area, that would tend to suggest the active phase of the MJO. And let's get oriented here. The equator right there. Here's South America, Chile, Peru, Central America, Hawaii, EQ right there, the equator. New Guinea right there, Australia. The all-important, dateline right there. All-important Kelvin wave generation area right in there on the equator. So this suggests, this is the statistic model, the CA model. It's a statistical model. Sort of uses past performance and how things have gone in the past to predict the future. All right, active phase of the MJO week, building 5 days from now over the Kelvin wave generation area. More or less holding 10 days out, and then weakening some 2 weeks from now. Now, the dynamic model almost suggesting the exact same thing. In fact, here we go. You look out the 15 days, 2 weeks out. That's the statistic model. That's the dynamic model. All this suggests the active phase building and moving over the Kelvin wave generation area over the next 2 weeks. It's been quite a while since we've seen this on any model, much less on both models at the same time. Phase diagram charts, the same two models, statistic model, the CA model here, and the dynamic model, the GEFS model. All right, the active phase moves from west to east, from the Indian Ocean over the maritime continent, over the West Pacific, over the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. All right? The heavy dot right there is where the active phase is right now. So right over the maritime continent. The further this dot is away from this circle, if it's more out here, then it'd be very strong. So a very weak active phase. And we have 1, 2, you can't even see it, 3 different forecast members here suggesting the active phase moving to the West Pacific and very weak, even weaker than it is now, 2 weeks from now. The dynamic model, a little bit more optimistic, suggesting the active phase pushing further east to, let's say, the East Pacific, and we'll say weak to modest in strength. So, but either way, this is all better than where we've been since July. The 40-day upper level model, all right? 8 different panels, 5 days each panel. South America there, Central America there, Hawaii, that 1 pixel. 0 is the equator. The date line roughly somewhere around in there. There's New Guinea, Australia. Kelvin wave generation area right there. So this is potential for precipitation. The yellows, drier than normal air. One can assume the inactive phase. And the greens, wetter than normal. The active phase of the MJO. So the active phase today over the maritime continent, moving into the West Pacific on December 3rd. This is in 5-day increments. Then moving to right in the core of the Kelvin wave generation on December 8th. And then towards the Central Pacific on the 13th, the 18th, fading and pretty much gone, trying to move into Central America right around Christmas time, while the inactive phase of the MJ, you can see it drier than air, starts moving into the West Pacific right around Christmas, makes its trek across the Pacific through at least January 7th. With the active phase, you can see it. It builds in the Indian Ocean and then starts moving across, moving out. So you can see right here, it moves from the Indian Ocean over the maritime continent, out into the West Pacific, the Central Pacific, and then it starts losing identity. Yes, it does move the whole way across the Atlantic, but the signature is not nearly as strong, and it wraps the whole way around the planet, and then eventually shows up back into the Indian Ocean and regenerates. And then the 1 month CFS model, and again, this is painting the same picture, but this is the whole planet on one chart, the date line running right up the middle. There you go. Kelvin wave generation area starts about 135 east, so right there is far West Pacific. All right, past performance is up here. The blues are easterly anomalies, the inactive phase, the MJO. The reds westerly anomalies, but then we actually get the benefit of having the MJO actually contoured here. The solid contour is the active phase of the MJO. This is an active phase that happened back in October. You see it had westerly anomalies, but once it got to the date line, those westerly anomalies were completely or destructively interfered with by the La Nina base state, and then westerly anomalies redeveloped over in the East Pacific. Inactive phase of the MJO, that's what we've been going through. It just faded about 2 days ago, and it constructively interfered. They call it interfere, but it actually paired up. The inactive phase and La Nina are almost like one and the same, making strong easterly anomalies that have been in control of the Kelvin wave generation area and are supposed to hold for maybe another day or two at best. And then here is our active phase of the MJO, and look at this, actually moving out to the date line, holding together somewhat with westerly anomalies in control to the date line. You can see it actually easing off from there even through December. The closest thing, not quite as good as this one, but the closest thing to an active phase that we've seen in a while, so we'll take it. Hopefully, and typically, the westerly anomalies are what feed energy to the jet stream, so hopefully this would be a good target for storm and swell production, and we're just starting to enter that window right now. And do recall, as we were in the early part of November, we went through a horrible flat spell with literally nothing going on. The inactive phase of the MJO and La Nina all paired up, just creating strong easterly anomalies. No energy transport to the jet stream. The jet stream was just a mess over the Pacific. Now all of a sudden, inactive phase is gone. Active phase is moving in. You look at the wave models, you look at the jet stream models, and all of a sudden, they're starting to light up and go, hey, it's almost going to look like winter again. So you can see the correlation and why we are so into tracking the active phase and the inactive phase of the MJO, because they really help give you a good look as to what's going to happen 3 and 4 weeks out from a surf perspective and also from a snow perspective. And then finally, the 3-month CFS model. Now, we say don't believe a model a week out, and we just showed you a model that goes out a month, and we kind of get a little excited about it. And then now we're going to show you a model that goes out 3 months, but it gives you at least a rough idea. Yes, this model is not particularly accurate, especially going out 2 and 3 months. It way overhypes, especially the active phases of the MJO. But it gives you a little tidbit as to what's going on, especially the low and the high pass filter. We'll get into that in a minute. But just looking at the overview look here. So this is past performance here. It's the whole planet again on one chart. The blues are easterly anomalies, the yellows, and if there were reds, are westerly anomalies, so active phase, inactive phase. Date line right up the middle here, and this is the forecast here. This is what's happened in the past. You see easterly anomalies in control right over the date line, and then just somewhere in the next couple of days they start fading. You see a distinctive trend of those easterly anomalies moving off to the right to the East Pacific, and you see a distinctive trend of westerly anomalies which have been locked over the Indian Ocean here, starting to make a trek across the Pacific Ocean. Just eyeballing this, not believing it, but when you see this, one typically would say, well, that should be the demise of La Nina. All right, so let's overlay some data. Let's dig in again. The MJO thing, there's our the solid contours are the active phase, the MJO. This is the one that happened back in October. You can read the scale here. Inactive phase, the dotted contour, this is what we're currently going through. You can see it amplified the easterly anomalies. But then what you see moving forward is, yeah, it's weak, but an active phase setting up December 6th or 7th, so about a week from now. Then a little pause, and another active phase, and another inactive phase, inactive phase behind that, but westerly anomalies just holding the whole way through. That's very interesting. What's driving that? Well, we look at the low pass filter, all right? So this shows you the general propensity for either high or low pressure, and it's your El Nino, La Nina indicator. When you have high pressure over the Kelvin wave generation area, that's La Nina. When you have low pressure over the Kelvin wave generation area for months at a time, that's El Nino. All right. The solid contour here is the low pressure bias. And where is it? Well, right now, it's about 100 east. That's over the Indian Ocean, maritime continent, if you will. But notice the leading edge of it here as we go over time starts pushing further and further off to the east. And so we'll just say somewhere around the end of January, it's supposed to make it roughly to about 170 east. We actually measured this pretty precise earlier. 170 east, that's 60% or more, 65, almost 70% of the way into the Kelvin wave generation area. That, and you see here, this dotted contour, that's the high pressure bias. You see it steadily getting shoved off to the east. And that suggests the demise of La Nina, or at least La Nina. So La Nina, El Nino, they follow the same path around the globe as the MJO does, but rather than on a 3-month cycle around the planet, they do it in let's say a 2-year cycle around the planet. So it's wave on top of wave on top of wave. Storms on top of the MJO, on top of the El Nino La Nina thing, and all these different weather waves, as they're called, they interact with one another. All right, so anyway, you see the general sense is, if one is to believe the model, that La Nina, at least from an atmospheric perspective, is to be fading out, and a El Nino-like, or at least a return to normal type pattern setting up in the Pacific, maybe as we get into February, if you believe the model. All right, so let's take a look down in the ocean. We've talked about this MJO type thing, but the El Nino, La Nina is really dependent on water temperatures and where the balance of warm and cool water is. So we look again at data from the TAO buoy array, that series of buoys strung across the equator used for monitoring El Nino. Here's the West Pacific here. This is the East Pacific here. We're looking, and this is just on the equator. We're looking down into the ocean, down 500 meters. It's really down about 150 meters. It really matters. This is, and these little X's here, those are sensors on the anchor lines on the buoy, on the actual buoys themselves. You see there's kind of a gap here at 140. I think there's another gap somewhere right in this area as well. But anyway, you take the data from the individual sensors, you run it through a model, and you use the model to fill in the gaps, and you get a profile. 28-degree isotherm, that's 28 degrees centigrade. That's warm water in the West Pacific, balled up at its leading edge at 180 west. That's where it's been for weeks now, unchanged. The 24-degree isotherm, maybe moving. I think it was about 130 or 135 west a week ago. Now to maybe 127 west, so trying to move off to the east a little bit. But again, it's not the actual water temperatures, it's the anomalies, differences from normal for this time of year. And what we see, again, 2 degrees centigrade temperatures where they've been for weeks now, all balled up in the West Pacific. Where's 50? Here we go, right here. 150 west, right there. Not moving an inch east of there, held in play, but the large noticeable difference is we had 3 degrees centigrade anomalies filling a large area right here. Now they're in a much smaller area and pushing off to the east, suggestive that whatever cold water or whatever is going on here, they call it a cold water Kelvin wave, it's pushing off to the east, maybe starting to erupt to the surface, and maybe finally being dislodged, hopefully for real. Here's another model, same basic layout. The cutoff, this one says at 160 west instead of 150, all the warm water there. Cold water here, but looking much less intense than weeks and months past. And we're actually putting this in motion here. This will take just a little bit to go through. Here we go. And you can see the cold water peaking in October, now starting to move off to the east. Less in intensity, less coverage. Certainly this is a good sign. That will open the door for warm water here to possibly start moving off to the east if you get the active phase of the MJO over the West Pacific with sufficiently strong enough westerly anomalies. Probably it's a bit too early in the cycle for that to occur yet, but at least it opens the door to hope. Next up, upper sea level anomalies. So this is not temperatures. This is the height of the ocean. Jason 3 satellite orbits around the Earth, a polar orbit. You strip out the wind waves, strip out the waves, strip out the tides, and is the sphere of the ocean higher or lower than normal? All right. Oh, there you go. Oops. Higher or lower than normal. Cold water at depth contracts. That'll create a divot on the ocean surface. Also, strong easterly anomalies that we know are blowing here also will scoop out water here, push it off to the west. Notice these are positive anomalies here, negative anomalies here, suggestive. Oh, and let's get oriented. Sorry. Chile, Peru here, Central America there, Hawaii right there. This is the equator. This is the date line. There's New Guinea right there. You see positive anomalies. So if you scooped out the water here driven by easterly anomalies, it gets balled up here. Also, if warmer than normal temperatures are at depth, warmer normal water expands a little bit. That'll create a bump on the ocean surface. So you get positive anomalies here, negative in the West Pacific, negative anomalies in the East Pacific. But the big thing to notice here is these easterly anomalies, this negative anomalies here are nowhere near as negative as they were a month ago. I think they were down to 25 centimeters. Now we're at 15. And almost day by day, the extent of this coverage is getting smaller and smaller. All that suggests is that what we saw in the previous animation, that the expanse and the intensity of the cold water at depth here in the East Pacific is starting to fade, probably getting pushed to the surface and erupting at the surface. And then the upper ocean heat anomaly chart, histogram, whatever you like to call it, going back in time. This is the East Pacific here, West Pacific here. This is water temperatures in the upper 300 meters of the ocean over the entire Pacific. You go back a year, December a year ago, warm water balled up in the West Pacific. Cold water, the peak, you can't see it here. It's off the chart. It happened like October 31st, I believe. And then you can see as we got into this year in March, the La Nina almost looked like it faded. We had an active phase of the MJO, Kelvin wave, warm water pushed across the Pacific, 1, number 2, number 3, and then we hit July and the whole machine fired up again. Here was our peak of cold subsurface water and much larger in aerial coverage than last year's event, about mid-October. But you can steadily see now that cold temperatures not over as large an area and not as cold, and moving off to the east suggested that the cold water pool is erupting to the surface. All right, sea surface temperature anomalies next. We talked about what's going down in the ocean. We talked about that cold water pool discharging to the surface. So we've actually been able to see it. A bit of it happened mainly over Thanksgiving. But let's get oriented here. Peru, Chile, Central America, Baja, the Bahamas, the equator, 0 right there. The blues, colder than normal water temperatures for this time of year. And you see a massive extent of colder than normal water, the typical classic La Nina sort of symptom. And the coldest of the waters are right here about 110 west. Now, a week ago and 2 weeks ago and 3 weeks ago, they were over a much broader area, going from about 140 to, I think it was about 110 right in here. Now, just a smaller area right here. We're thinking that maybe a good bit of that cool pool subsurface has erupted to the surface and is already tracking off to the west, being carried by, trades being driven by high pressure circulating this way right here. And same thing, high pressure in the southern hemisphere also feeding trades this way. Both the highs stronger than normal, creating stronger than normal easterly trades, creating stronger than normal upwelling here, and then you have the cool pool at depth erupting to the surface, and you get La Nina. We're hoping, or at least we're thinking, that maybe the very worst of it is over. Sea surface temperature trend for the past 7 days. We actually see Whoa, I'm sorry, Peru, Chile, Peru, Central America, Hawaii, dateline, the equator, and the dateline right there. I'm getting ahead of myself because I'm a little bit excited here, actually. Warmer than normal waters building off of all of Central America. Now, this doesn't mean that they are warmer. See, they're still colder. But compared to 7 days ago, they are warmer than normal and building off of Ecuador. And the cooler temperatures were actually, we've been watching this day by day, they were covering a much larger area 2 weeks ago. They're still there. They're pretty cool, still cooling as that subsurface pool erupts, as trades still are pretty strong in this area, but not as bad as it was. We really want to see a building swath of warming temperatures. You see it in pockets here and there, but it's still sort of a 50-50 split. Colder, warmer. Yeah, we're cold, but we're not getting any colder, but we're not getting any warmer, except for right here along Chile and Peru. We want to see that start building here, and it's just over the equator, right? This whole thing, this whole mechanism we're talking about, feeding energy to the jet stream and Kelvin waves and all that, it all happens, it is all generated just 5 degrees north and south of the equator over this stretch of the Pacific. Mainly, though, over here. But still, you get, it's just a tiny little area in the Pacific can alter the jet stream over the entire planet for years on end. La Nina, for example. 2 years we're in it, all driven by what's happening right here. And then the backed off view here. Again, still there's the peak of our cool upwelling. That's right about where we think the max of the cool pool subsurface is. It's upwelling to the surface. A little bit of warming here, supposedly. But overall, I mean, yes, it's still La Nina, but this doesn't look as intense as it did even 2 or 3 weeks ago. So maybe we're moving in the right direction. Sea surface temperature trend in the Nino 1.2 region. This is the area on the equator right there by Ecuador and the Galapagos. Temperatures, well, they bottomed out at about 1.75, maybe 1.78 degrees. But on the rise, at least for the moment, 410 thousandths of a degree, 1.4 degrees below normal. Pretty cold. But this is not the official El Nino monitoring region. This is the Nino 3.4 region. It's on the equator, the area south from California, 120 west out to about the dateline, 170 west. Temperatures today, 833 thousandths of a degree below normal. La Nina starts at a half a degree below normal for 5 consecutive months periods. We've only been in La Nina territory since, we'll say, the end of September. Here we are in November. So October and November, 2 months, but clearly cold water has been in effect in this area for a year and a half. The jet stream is affected by that. If you have colder than normal surface water, above that, you typically have stable air because you don't get evaporation. That supports building of high pressure, and once high pressure gets locked in, then it pushes the jet stream north or south, and you get sort of just a dead zone in terms of storm production and swell production. Temperatures today, holding steady. We want to see them increasing some. Probably that's not going to happen for another month. There's still quite a bit of cool water at depth that needs to erupt to the surface, but we're moving in the right direction. Finally, good news after a year and a half. So we talked about that evaporation and how the surface ocean temperatures affect the atmosphere above it. So there's an index, the Southern Oscillation Index, difference in pressure between Darwin, Australia, roughly in the Indian Ocean, and Tahiti in the Pacific. If there's lower than normal pressure over Tahiti, the index goes negative. If there's higher than normal pressure over Tahiti relative to Darwin, the index goes positive. Today, it's plus 6.42, and you can just eyeball down here. 2 days ago, it was at 30.98. That's really high. And you can just look back the entire month. It's hardly been negative at all. Again, suggesting La Nina is in play. No big surprise there. The 30-day average takes some of the noise out of this. A plus 11.24 and it is rising compared to a month ago. So again, a building La Nina, or at least a building inactive phase of the MJO. And if you remember when we showed the charts earlier, this La Nina, or the inactive phase of the MJO, has been building for 2 months over the West Pacific, and the active phase hardly has put a dent in it. So we're still on that trend for right now. It's going to be really interesting to see if in the next week we can't start to see some negative numbers here and start to get this value dipping. The 90-day average, the La Nina El Nino indicator today, 9.79, positive as well. Where has it been? Well, actually it's not too bad. A little bit above where it was a month ago, but if I recall, this was up to about plus 16 at the peak of last year's La Nina, and this went up to plus 19. So we're not as bad as we were last year, at least so far. Here's the 30-day moving SOI graphed out. Going back in time, January 2019, we were in a weak La Nina. Negative values of the SOI reflect El Nino. Positive numbers over a prolonged period of time reflect La Nina. Then we started July 2020. You see, we went positive to 20 or 19, depending. There's a couple of different ways to run the numbers here, but this graph says positive 20. The downward spikes are the active phases of the MJO. The upward spikes are the inactive phase of the MJO. Clearly you can see the inactive phases are dominant over the active phases, hence La Nina. Then we had a bit of a break this July. We had some Kelvin waves, and now we're muddling along. Where were we last year in, let's see, November, almost the beginning of December? We were negative actually then, but coming off a run at about 10, that's pretty much where we are right now. The question is, are we going to get a big spike like we did here in the beginning of January? Maybe, maybe not. It seems like we're moving towards the active phase of the MJO right now, so maybe this is as high as we're going to go and it'll level off, and that would actually be a good thing. Finally, sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region, that area on the equator from south of California out to about the dateline. Temperatures, according to this, the raw data, dropping to minus 1.5 degrees below normal. This is actually a pretty good upward re-estimate because we were down at minus 1.75 or something like that even a week ago, I think, or 2 weeks ago, and then supposedly returning to a neutral state as we get into July. The PDF corrected version, which is probably the more accurate of the two, suggests temperatures only going down to minus 1.25 below normal, and we're probably about there right now according to this, so things not getting any worse and improving beyond that. So maybe, just maybe, we're at the worst of it right now, which isn't so bad. So for right now, an improving pattern is setting up. That is, we have swell predicted on the models, seas of decent height aimed both at California and Hawaii, so some surf in the forecast, and we're actually coming off a pretty decent run past couple 2 or 3 days of swell, and by all accounts it looks like there'll be more swell coming with the active phase of the MJO building and taking over through at least mid-December, something like that. That's good news, meaning more energy in the jet stream, more potential for storm development, and maybe even some precip in the forecast for down into California and Oregon, and snow in the mountains. Maybe not a lot, but any little bit is good. Last year we were at 42% of normal. I've got 6 inches in the rain gauge here in San Francisco, so the real of rainfall so far this year. We'll see if we can get up into the 15 or 20 inch category. That might set us up pretty close to normal, maybe not quite. I think it's more like 25 inches, but either way, anything is better than where we were last winter, and right now all the indicators are suggesting the cool pool at depth is erupting to the surface, probably won't be replaced. The active phase of the MJO looking forward is supposed to be building in more towards a normal pattern. Westerly anomalies setting up more over the West Pacific, long term, probably helping to nudge us into a more neutral pattern, and the low pressure bias, surely but slowly inching its way back into the Pacific from being over the maritime continent for 2 years, and maybe we're heading back to normal. Now, if all that stuff happens even in February, the jet stream isn't going to magically just go back to normal. It's going to take 3-4 months for it to really get back in shape. So what we're really talking about here is the forecast for next fall or maybe mid next summer, which is a long way out and highly speculative. But the suggestion is that as we get into next summer and fall, we could be back in a normal pattern, and that would be really a good thing. We're tired of paying our dues. We want some icing on our cake. We want some surf. We want some snow, and we want it now. All right, so that's our video for this week. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Ring the bell. You'll get automatic notifications when we post the video. If you don't want to do that, all the data you saw tonight is available on stormsurf.com, and the link to the video will be posted at the top of every page on that site as soon as we post the video. You can get to it that way. Build your own forecast using all the tools and all the imagery that you saw tonight in this video. It's available on the website there. Build your own forecast, compare it next week, next Sunday in the evening, to the video that we'll build then, and see how accurate or not you were. And if you have any questions, the comment section is the place to do it here on YouTube, and we'll try to reply pretty quickly and give you any answers that you might have. All right, thanks for watching. Go get some surf, have some fun, enjoy time with family and friends, and we'll do this again next week, same time, same channel. Thanks for watching.